All right. On Tuesday, we went through concentration. Concentration is just a way to measure how much of a certain substance is dissolved. Okay? What do you think the concentration of salt water would be in the Dead Sea? Anybody know? Everybody hear about the Dead Sea? It's
super high.
yeah, it's so high that there's hardly anything living in the Dead Sea in Israel.
Isn't it like you can float in it without too much?
Right, I heard that you could go out there and even if you're skinny, you would float higher up on the water. It is super salty. So we say it's really, really concentrated.
Is there
Okay?
fish in it at all?
No. Dead Sea. Dead Sea. Too much salt content for even something in the ocean to live. So we're talking about how much of a certain substance that is dissolved into a solution. The Great Salt Lake City. That is a lake that is salty. Most lakes are fresh water. They don't have salt content. Okay? So concentrations are important in telling you how much of a solid you have in a solution. So I have sulfuric acid. Really, really nasty stuff. You get it on you, it's going to burn you. You get it on your clothes, it's going to eat holes through your clothes. This is 18 molarity. Well, what does that mean, 18 molarity? So you're saying, well, I don't know. There's 1.8 kilograms or 1,800 grams of a solid dissolved in a liter container. So a liter container, okay, liter pop you can think of. There's almost 1 kilogram of solid dissolved in water. So taking a chunk of this, and this was H2SO4, and dissolving it into about that much water. A little bit less than that probably, because that's probably about a liter. Okay? So that's really, really concentrated. Okay? And so concentration, we could have dilute. So when I prepare this for you to do in lab, I have to dilute it by 18 times. If it's like a 1 molar solution, then what I have to do is for every 1 milliliter of this, how many milliliters of water I have to have is 18. It's got to be an 18 to 1 ratio. Okay? So 1 liter of this, or 1 milliliter of this to 18 milliliters of water. I have to dilute it. Yeah, it's strong. It's strong. And they sent it to me so that I can take and use that over a long period of time. Use it over a long period of time. There's these guys that go out and sell product. And they're cleaning product. They do it in the summer. They earn money. And so they bring around this cleaning solution, but it's a concentrate. And they have a bottle that goes with it. And they said if you want to clean windows, you have to add so much water, some of this solution. And if you want to clean like stovetop, you need more of this solution, less water. You need it more concentrated. Okay? So that's what concentration is. Within the solution, which is homogeneous, you have a solvent and solute. The solvent is the substance that's doing the dissolving. Okay? It's just, so if I add this here to a lot of water, which is my solvent and which is my solute? So I've got this, I take a little bit of this and add it to a lot of water. What's my solvent going to be? Water or this stuff? Well, this is going to be the stuff that's going to be in lesser amount. It's going to be dissolving. Okay? So the one that's in a higher quantity is the solvent. Okay? Solute is usually a solid that we're going to talk about, like sugar or salt, any solid that we can take and dissolve. Okay? All right, you guys all have these notes down for the most part. And so we're going to go to the problems. Now I'm going to have these online. So any notes that people have missed can go online and I'll show you where to go to get those. All right. This is a problem, or this is the second part of the notes dealing with molarity. Any questions with this? So, one way to measure concentration in chemistry, we do it all the time, is by molarity. Molarity just means you got so many moles of solute. The more we have, the more concentrated it is. Less we have, less concentrated it is. It's divided by liters of solution. Okay? Right? So, when we do problems later on today, that's the formula you're going to use. Any questions about finding molar mass? Brock, any questions about finding molar mass up here? Okay, you know how to do it? Okay, Adam, you know how to do, find stuff. Ask you, what's the molar mass? You know to add them up. So what information does that give you? Now, I'm trying to simplify this. So let's say, anybody in here ever worked at a grocery store where you had to weigh out your stuff to buy it, like produce? Okay? So when you, like say I want to get apples, and I get about 3 apples in the bag, and I put it on the scale, what do you have to do to see what price I have to pay for that? Okay, that's kind of what this is. It's not a dollar amount per pound, but what it is, it's grams per mole. So if I had a mole of something, that's how many grams it would weigh out to be. So it's the same idea. Let's say apples are, $3 a pound. So if I got up 2 pounds of it, how much would I be paying? $6. You guys do that. If I have 2 moles of this, and this is how many grams per mole, then how much do I have in weight? You could calculate it. It'd be twice that much, right? It'd be like 156 grams. If you can do money, you can do grams per mole. It's not that different. Some people like to make it different, but it's not that different. Here's another example where we just figured out grams per mole for the whole thing. We did that yesterday. Also, what we did yesterday was we did a conversion. See, this is like that I got 2 pounds of something and it's $3. Okay? It's kind of something similar to that. So here I have 120 grams and I want to convert to moles. I've got to make sure I put my units to where they cancel out. So in my conversion ratio, which is 1/78, my grams cancel. My grams cancel. I have moles. Here's the problem. Students don't know whether to butt. This is what's happening. I don't know what's taking place. They put the 78 up here, and over here they put the 120. I constantly see 78 here, 120 down there. That's saying you got 120 grams, you got 1 mole. But that's a lie, because we've already calculated that there's 78 grams in 1 mole. So don't do that. What I give you goes out in front, and then you have to convert it. Okay? Don't make up your own method of converting. Here, I gave you 40 grams. It goes out in front. Grams cancel into moles. 1 always goes with moles. Okay? 1 always goes with moles. Here I switch things up on you on this one. Here I said how many grams? Okay? 1 mole. See, moles are on bottom now. I put the 1 mole. I don't put 36.46 moles. I put 1 mole is equal to 36.46 grams. Okay? Depending upon what you need to cancel. Okay? All right. We did this yesterday, right? Did we do this yesterday? Okay. Let's do that. Now go back to your notes and do the calculation for molarity. This is about as simple as you can get of the problems we're doing. So look at your equation for molarity, which is moles over liters, and calculate the molarity of that solution. You will want this on the test. If you had a choice of having this on the test, you'd want this question, because you'd get it right. Okay, so 5 molarity would be your answer. Next one. Go ahead and write out this sentence and tell me what I need to do to solve for the molarity on this one. Do we have a way to measure moles with instruments in class? Have you ever measured moles with anything in class on like a scale or anything? Okay, you haven't. So what do you have to use to measure moles indirectly? Grams. So when I'm doing this in class and I want to measure something out to make a concentration, I have to measure out a mass in grams and then convert it to moles. So tell me what I need to do in this setup to change it to where I can find molarity. So that they can see it. So there's a setup. Any questions? All right, the next one I want you to do on your own. There's a little bit of a twist I'm going to do on the next one because in class I really don't measure solutions out in liters. A lot of times I have smaller amounts. I deal with milliliters. So can anybody tell me what I would do if I want to convert milliliters to liters? Do I divide by 1,000 or multiply by 1,000? Yeah, you divide. So if I have something that is 1,500 milliliters, I divide by 1,000, I get 1.5 liters. Okay? So here's the next one. We're just going to go ahead and right away and tell you that 300 milliliters is how many liters? 0.3, right? Because you take 30 or 300 divided by 1,000. Okay? Since 6th grade, you've been doing conversions. Milliliters to liters. Liters to milliliters. Okay? So there's 1,000 milliliters in a liter. You take 300 divided by 1,000, you get liters. I'm giving you the molar mass. The NaCl, the last one we did, was 58.45 grams. We calculated that. Sometimes I'll give it to you. You don't have to do that step. So all you have to do is convert the 80 grams into moles and divide it by the liters. Go ahead and do that. It should only take you a couple minutes to do it since you don't have to figure out the molar mass. So that's how many moles you'd have. Now it's really easy because then what we do is divide that by the volume. So we look at the volume. We divide it out because we changed 300 milliliters into liters by dividing by 1,000. So then our final setup is 0.23 moles divided by 0.3 liters. It gives us 0.77 molarity. Got the answer. Okay. Would like you to get 1 and 2 done. You guys have 10 minutes. 1 and 2 has 3 parts, but they're all pretty easy. So before you go, so I can see if you're setting these up right, I'd like you to do 1 and 2. And number 3 is dealing with molarity. But 1 and 2 is based upon what we talked about yesterday. See if you can do 1 and 2. Austin, you can retake that test either today or tomorrow. I'll give you your test back. You can look it over. And you can...
Just figured I'd do it.
Yeah, but you got to get in there right away because what happens is with the test, it takes a little bit longer to do. So,
I normally get in there pretty early.
okay. And then I'm going to write some notes on here and give it to you to study. And you can look it over. So 1 and 2, what you're doing, 1, you're finding the molar mass.